Hi, I'm Nick, and in this video, I'm going to tell you all about breadboards and how they're used to build circuits. A breadboard is like an electronic version of a Lego baseboard. It's a place for you to build all of your circuits, but when you're done, you can take it apart and reuse the parts and build many more different types of circuits. Every electronic device you've ever used has started out like this, something built in a breadboard as a prototype. Once it works, we can take it, we can miniaturize it, and we can make a million of them. We use a breadboard as a tool to connect wires in a way that won't be permanent, so that we can plug them in and unplug them, just like we would build Lego bricks and unplug them. It allows us to quickly make connections by plugging the wires into the same row. But why is it called a breadboard? Well, the word breadboard comes from the early days of electronics. Back in the day, bread came in a form that was not pre-sliced. It came in a loaf. Everyone had a special cutting board in their kitchen just for cutting bread. They called it the breadboard. I think there's a pun in here somewhere about electronics and the best thing since sliced bread. John. If you could come up with something good, put it in the comments below. That is sour. So back in the day, when you wanted to build a circuit, you would steal the breadboard from your kitchen to do a little engineering. So let's see what it looked like when our forefathers built circuits in their kitchen. You would nail copper nails into the board, and then you could wrap the wire around the copper to build your circuit. I've built a few of the LED and resistor circuits we saw in the earlier video. In this case, I'm powering with a battery, so the last connection I need to make is the battery to a nail so that current will flow through the circuit. And there you have it, a little piece of electronics history. But it was a lot of work to build, and it's going to take a lot for me to change how the circuit is laid out, to build something new. So the modern breadboard is going to take this concept and make it a lot easier for us to prototype. It's going to be more like playing with Legos. In order to show you how modern breadboards work, I took one apart so we can see what's inside. Don't do this yourself, it makes a whole big mess. As you can see from the top side, there are 5 holes in a row. From the back, we can see that those 5 holes are all connected to the same piece of metal on the inside of the breadboard. I popped one of these metal pieces out so that we can see what it looks like. So when you put a wire into this piece of metal, it kind of slides in like a spring. This is what's happening on the inside of the breadboard when you plug a wire in. So how do we use a row in the breadboard? We're going to use it just like we used a nail. We wanted the LED to touch the resistor, so we wrapped them both around the nail, so that it uses the nail to conduct. On the breadboard row, I want to put the LED in the same row as the resistor, so that the resistor is now touching the LED through the row, just like it was touching the nail. You can see that the LED and the resistor are both plugged into the same bar, just like they're plugged into the same nail. The modern breadboard has some cool features. Notice that the holes on the sides are connected as columns, not as rows. So that if we jump over into one of these columns, that voltage becomes available all the way down the sides of the breadboard, and it continues down to beyond where I destroyed it. In the middle of the breadboard, the rows are connected with 5 holes each, but the rails have lots and lots of holes that extend all the way down the sides of the breadboard. Big circuits like this need a lot of connections to power and ground. That's why these columns are so long. Big circuits are actually collections of little circuits, and each little circuit will need a power and ground connection. So that if we put power and ground into the rails, we'll have lots of places to tap off. We're going to use our NLab to define what these columns are for. The NLab puts ground in the leftmost column, minus 5 volts, which we haven't used yet, in the next column, plus 5 volts here, and then ground in the rightmost column. A standard breadboard has 830 holes. But if you have a smaller project, you can buy even smaller breadboards, some that have rails and some that don't have rails, and even some that are semi-transparent so that you can see the metal inside. If you have a really big circuit that you're trying to build, breadboards have keys next to them so you can plug them into each other to make really big, epic circuits. Just like Legos. We always come back to Legos. So to sum up, the breadboard is the best tool in your electronics bag. You're going to build thousands of circuits on your breadboard. To me, it's my scratch pad. It's where I go to design things. I hope you enjoyed this deep dive into breadboards. Until next time, I'm Nick. Thanks for watching.